All fine, all fine. Before we start, let's talk about time for our sessions. Do you prefer like 30 minutes or maybe 40? What do you think?
Yeah, I think it's let's keep 30 minutes. Yeah, I don't know, like if it takes. I mean, I'm not sure. Like, let's keep 30.
Mm-hmm. Okay, yeah, 30 also good for
Mm,
me.
cool. All right.
Yeah, let's start.
So I think it's my turn to uh, get interviewed, right? So
Yeah, that is for you.
cool. Okay, let me give me a minute to just read the question and then we can.
Mm-hmm.
So we are given two words, source and target, and list of words. Find the length of the shortest series of edit that transforms source to target. Jacobs exactly one letter at a time in each individual letter. We were to find out what's exist. Okay, so we are given like a source word and a target word, and we are given a list of words, right?
Right.
And then I have to find the length of the shortest series of edit. So, taking this example, it's bit and target is dog. So we are gonna convert um, bit to okay, bit to but, uh, and then from but to I'm gonna go to okay, makes
Mm-hmm.
sense. Bit to but, and then I'm gonna iterate each character put, and then I'm gonna do big, and I'm gonna do put. Okay, so what I'm thinking is, assuming like I stored these words in a dictionary, not a dictionary, but a try.
Mm-hmm.
Uh, and then what I'm gonna do is I'm gonna iterate over each letter in the source word.
Mm-hmm.
So let's start with B. So index zero. So at B, I'm gonna find if there is anything that exists. So my index is zero here. My word is bit. So at this point, I'm gonna find if it's gonna be turning out like a tree. So So from bit, I'm gonna start index zero. I just need to check if there is anything that exists in that ends with it in the try. So my try will have like two methods: starts with and ends with. So I can maintain two tries: one which stores the word in the same order, and the other try which stores the word in like reverse order.
Could you try to draw it?
Sorry.
Could you try to draw it? Draw this try.
Yeah. So yeah, it should be something like this. B IT, and then will be again there is put here UP.
Yeah, and let's add but.
Yeah. So and then there is gonna be B U P,
Mm-hmm.
and then I will similarly have like a try which will be storing words in reverse order. So what I'm gonna do is gonna be having like uh, so
T.
bit is T IB, and then but is gonna be TUB. No, this is U is fine. This is B. And then again, this is going to be TUP, TU,
Yeah, and that's it.
yeah, TUP. So, yeah. So now I'm going to check at each point, like at each letter. I'm at line 20. So I'm gonna check if there is anything. This is T1 and this is T2. So I'm gonna check if there is anything in that is ending with UT. Uh, so that starts with UT, and in my reverse try, and I don't see anything that starts with UT. So I will have to index plus one.
Mm-hmm.
My index is gonna be one, and I'm gonna replace I. So at this point, I need to check all the words that are possible that starts with B and then ends with IT. Sorry, ends with T. So in this case, my only word possible in starts with will always check in the first try. So the words that start with B is BIT and BUT, and ends with T, which is gonna be here, and it's gonna be it's gonna be bit and but. So we are already at bit, so that's the source word. We are gonna skip that. So we are gonna replace bit to but now, and we're gonna start this process again. Now index is zero
Wait,
again.
can I ask? Uh, that here, like you're talking about but, right? But what if we have a word?
So at this point, the
No, give me a sec. But what will be like starts with B, right? And ends with what?
sorry.
Uh, in on line 30, I've added the same code. It starts with B, right?
Hmm?
And ends with what? What should be here? I'm not sure that I understand your idea.
Ends with what? So yeah, I'm just pretty much iterating. So I mean, so at this point, I was at. So this was bit right, and my index was one. So I divided the word into like this is going to be one substring and this is going to be another substring. So
Mm-hmm.
substring like I'm going to find strings of words in the try that starts with prefix B, like index
Right.
minus one substring, and then I'm going to find words that end with index plus one substring. So that ends with
Mm-hmm.
T. So in this case, I only have another option is but, which follows the same rule. So this will give me but option here, right? So I'm going to replace this to bit to bird because that also exists in the dictionary. And then I'm going to start with index zero again. So I'm going to start my algorithm again. Uh, in the algorithm again, I'm just going to see index zero. Is there anything that is available with UT in my dictionary in my try to? So there is nothing that starts with UT in like reverse try. So I'm gonna index again, gonna put it to one. At this point, no, so UT there is one. So yeah, so we are at this and UT there is but and put, right? So I'm gonna find if there is anything that starts with sorry, ends with UT, and in this case it's gonna give me put. So I'm gonna replace but to put. Now my put is the new word, and I'm gonna index zero, and I'm gonna increase my count to every time I do this operation.
Yeah,
Like
but what if here will be put like toot and could?
I mean, those are not in dictionary, right?
Let's imagine that they are in this dictionary.
So yeah, I will iterate over each word. I will try all the possible combination, and then will try to find.
Okay.
Uh, I will try to find the possible combination where I can reach the target
Uh-huh.
uh, word, and then I will have to return the minimum number of length, right? Like
Yep.
I will be maintaining like in all the path possible. I will be maintaining like the total count, and will
Mm-hmm.
find the minimum of those total count, and will return them.
Mm-hmm. Okay.
Yeah. So in this case, I'm thinking, is there anything better that I can do in terms of? Yeah, let me just talk about time complexity since I think we are only given. Is it said that the words can only be like all in lowercase?
Let's imagine yes.
Okay, so then I think my try will be a constant time. I mean, if we only have 26 characters, right? So storing words
Mm-hmm.
into try and searching for ends with and put starts with, this will always take off n raised to power 26. Sorry, 26
Uh,
to power n.
yes.
So, and since 26 raised to power n will be a constant number, so at this point, we can say that it's not going to be exponential. But if it was not lowercase letters, it can be anything, then it would have been an exponential algorithm. So that's the advantage that I'm going to get with try. And also storing, we will have to store the length of the words, and each child, I mean, each try node will have 26 children,
Mm-hmm.
26 characters. So again, the space is of 26, which is again constant.
Yes, but you can have n levels.
Yeah, we'll have to have the level. So that will be the average of the length of words,
Mm-hmm.
like the maximum of length of words. Um,
Okay. Yep.
do you want me to?
What
Uh,
about time complexity?
so time complexity for shortest word path, right? So in this case, I would be going from each possible path, right? Um, so source to target. So let's say the time complexity is length of sources. I mean, if the length of source and target is not equal, the base case would be just written that there would be no possible, because we can only substitute words, right? We cannot add or delete, right?
Mm-hmm.
We can only change one letter at a time, so we cannot delete or add.
Yes.
So it should be of n raised to the power. So we have to search, right? Um, so for every character, I'm gonna be looping through my starts with an end with, and that's
Mm-hmm.
gonna be of 26 raised to the power n, which is gonna be of n again, because 26 is a constant, like characters is constant, so um, it's gonna be of n, assuming that we have lowercase letters.
That's interesting for me how you can do it, but let's try to implement it.
What do you mean by like? I mean, am I saying something wrong in my time complexity, or?
Now I want to see this implementation. It sounds interesting.
Okay, yeah. So, given I think the time we have, I will not be able to implement like a complete try and also the word and also the method. So what I can do is I can create a class structure,
Mm-hmm.
uh, and then also I can like assume that a method exists with starts and end, and if the time permits, I can code that up too. But for now, I can assume that I will start assuming that I mean I'm not gonna be implementing these two methods right now, because this comes like starts with comes with I mean starts with comes as a like a method already
Mm-hmm.
inbuilt in try, but I can code it up if you want to, but we don't have that kind of time right now. So I'm gonna assume that that there's a method that exists called starts with. So in this case, it's gonna be public class try, and then it's gonna have like a generally has a try node, which is generally a root, and then should also have a class called try node. Uh, and try node is the basic node, but what it's gonna have is like boolean is end of word, and then it's gonna have a character ch character that particular node, and then it's gonna have like a list children try node, and then again it's gonna have like a public constructor and stuff like that. Um, so it's gonna take in char ch, and it's gonna take in boolean end of word. So in this case, this dot ch is ch, and this dot end of word is. And then we're gonna have children is equal to since we only have 26 characters, so why not? It's going to be 26 here. And similarly, this try method will have like a method, like this try class will have a method called public add word. I'm not going to implement that right now. I'm not taking like a string word, etc. Or like add word, and then there would be a method called like add words. I'm taking list of string. So yeah, in the main method, and then there would be like a method called starts with. Uh, it will give me a list of possible words with the prefix. It's going to take a prefix here. And then these are the three methods that this try will be having. And in the code, I will be having like a try uh, one, which is going to be new try. And then we are going to add p1 dot add words. So it's a string of words, right? So I'm going to take two. I'm going to make two lists. So one is going to be the word list, which is just the input words, and then there is going to be like an another list, which is going to be the reverse of the like, which will just be a list of word which are reversed. So yeah. So what I'm going to do here is I'm going to be iterating for string word and words word list dot add word, and then it's going to be word list sorry reverse list dot add. um, I'm kind of I'm not sure if there is a method called reverse. Is it okay if I look it up? Like, is there a method to reverse a string?
Yes, we can skip it.
String reverse. I think
Oh,
there is.
you can skip this method. Like, okay, let's imagine that we have this method.
Cool. Yeah, so we have like two lists now. One with just the list of words, and the
Hmm.
another one is just the reverse of the words and stored in as a list. So we are gonna add words to t1 dot add words word list, and then similarly I'm gonna have two dot add, which is like a reverse word list. So in this case, I'm gonna add reverse. Yeah. So now the actual algorithm is so I will be passing having a helper method. Okay. I need to maintain like a minimum. So I will be having like a static minimum. Um, so I'm going to pass this helper to source target, and then T1 and T2, and then index, and then sorry about that. Yeah, so this will be like a helper method that I will be having. I'm gonna be implementing that. What it's gonna do is it's gonna be returning me like a length of uh, uh, so return -1 for now. And then what I also need to have is like a minimum length. So integer min length is equal to integer. I'm gonna be initializing it with max value, and then I'm gonna keep updating that. Uh, okay, so um, yeah. So what I have to do is I think the base case is if source is not equal to target, if source dot length equal to target dot length, return -1. We have to return -1, right? If it's not possible,
Yeah, let's do it.
yeah, I think it is. It says that one except it's going to be -1. And then, okay, so we are at this point, and what I'm going to do now here is, um, so, okay, yeah, from source, I'm going to start with this. Okay, so I think I need to iterate over each character, integer I, source dot length, I plus plus, and then I'm going to pass I here. So my helper method basically will be returning me, and then at the end of it, I need to have return min length, and then my min length will be math dot minimum min length, and then the helper. I mean, whatever I'm getting at each point. Yeah, so I'm gonna start iterating, and what thing I need to do is T1 is my try one, and T is try two. Cool. So yeah, if my source is equal to target, my source is equal to target, then pretty much I have found the word. So I'm gonna um, return return one. Otherwise, otherwise, what I have to do is there is string source, string target, source dot equals target. Yeah. Otherwise, I have to what I have to do is I have to like recurse, and then while recursing, I have to see like I have to find a list of words,
Hmm.
list string, uh, list string uh, starts with. In this case, it's gonna be so source. Yeah, T1 dot search. T1 dot starts with. Also possible. So yeah, I mean prefix list and suffix list. So starts with I'm gonna be passing like source dot um, I'm going to be passing source dot substring. Yeah, I think there is a method called substring, and then I just need to have index -1. Yeah, I think it's index. That's the upper limit, and then I'm gonna be having like a string of suffix, which is gonna be e2. So it starts with um, source dot substring index +1.
How do I want in first case from 0 to index, right?
Yeah, 0 to index. Yeah, sorry, that's correct. So I will have prefix list and suffix list. So I need to find like a common solution between those. So let's say we have another method called public uh, list of string possible possible options. So it will take like a list of string A and B, and then we'll just try to find like common. This can be done in like using a set, and then can be find like we can eventually find what are the common words in it. So list A and list of string B. Also, we are storing the um, so I would say possible solution for the base Also, we are storing list B into reverse order, right? So we are storing
Mhm.
try in reverse order, so we will have to somehow reverse the words again. Uh, and then it's going to be return possible ways. So what I'm going to do here now is, let's say if this method exists, I'm going to be getting like the list of string possible ways. There's going to be possible options, and I'm going to pass prefix list and suffix list. And
Can you, before you continue on line 52,
mhm.
could you show me result of this method? Like, can you add it here? I'm not sure that I fully understand what you will have here and here.
Yeah, so prefix list. So I think we started with the word called bit, right?
Yes, we start with bit, right?
Yeah, so my index is zero. So this my first substring will be like an empty string.
Mm-hmm.
My first prefix will be an empty string. So there is nothing in that. I mean, if depends on how I implement the
Mm-hmm.
try. So there can be like it will give me all the possible options,
Mm-hmm.
which is gonna be in this case the output of this will be
Mm-hmm.
this, and in this case this is a suffix, right? So my suffix
Right.
in this,
You said that in starts with, in first case you will have an empty,
yeah,
right?
start kit it's gonna be an empty.
Okay, let's
No,
go.
no,
Let's say,
no. Starts with will have like everything, right? Starts with nothing, right? So it will include everything in the try. So
why do
start
you mean starts with? Oh, okay, yeah,
because yeah, it's an empty string. Like prefix is empty, right? So
makes
it can
sense.
be yeah. So it's gonna be starts with, and then in the suffix list, I'm gonna be finding ends with or starts with the remaining letters, which is
Mm-hmm.
IP, and it is gonna be
Okay.
returning me. So since it's in inverted order, so I'm gonna be finding words that ends with IT,
Yep.
right? And seems like there's nothing that ends with IT.
Nothing. Empty.
So this possible ways will be empty.
Yeah. Okay. Possible ways empty. Let's go. Let's try to iterate next.
Yeah. So this possible ways is empty. Now what I'm gonna do, my algorithm, what is gonna do is it's gonna iterate on the all possible ways. So since it's empty, so what I'm gonna do is for string uh, possible words, what's a word in possible ways. I'm gonna iterate this algorithm uh, on by changing my source to be
Mm-hmm.
uh, it's gonna be recursive method, and source is gonna be here. Source is gonna be word. Target is still the target, and then my T1 will be the same try T2, and then I'm gonna be passing index is equal to zero because I will have to restart my
Mm-hmm.
algorithm.
Okay. Let's try to iterate to the
So
next
yeah,
loop.
and I mean if that doesn't happen, otherwise I'm gonna be iterating on this method, right? That's helper, and then it's gonna be source. So yeah, source is fine. Everything will remain same. P1, P2, source, target, P1, P2, P1, P2, and then we are gonna increase the index. So if we are gonna iterate over this, so I'm back again into this algorithm. I mean this helper method, and my index has been one. So my source is still bit because I'm not changing the source here at line 72. 73. So the source is still same. My index has become one. So my starts with will be starting all the words starting with B. So in this case, I will only get but, right? And then,
I'm not sure. Wait. You have a beat, right?
huh? Yeah,
You
I
have a
have,
beat.
yeah, I
Then
have
you moved index to the next element, and now you have
index is one. So I'm gonna
your
be
prefix should be
prefix is B, right?
two.
Prefix is
Yes.
so in the first try, T1 will be returning me but, right? Because the only word
Okay. Yeah. What about big?
bit will not be there. So I will have a base
Why?
case. I mean, we are gonna skip the word that is already the source word. So otherwise we'll be stuck in the loop, right? Like
No.
so
Wait. You use beat. Beat. But what about word big?
Huh?
What about word big?
There's no big in the word, right? Oh, okay. Sorry. Yeah, I forgot. Yeah, there will be two words, but and big, both.
Okay.
Everything that
Uh,
starts with B, right? And then the suffix list will be giving me uh, everything that ends with T. So everything that ends with T is but, put, and lot, right?
yeah.
And
Let's
pot.
let's edit. Let's edit here.
So yeah,
But
but, put, pot, and lot, right?
all right.
So in this case, the common word that is possible is but and I mean that's the but, right?
Mm-hmm.
So my source will become like possible ways will have a list which has only but. So
Mm-hmm.
my now in next iteration, my source has become the word but.
Mm-hmm.
So I'm gonna be starting with zero index. In this case, in my next algorithm iteration, it will be bird index is equal to zero, and again I will repeat the same algorithm. I will start with everything that ends with ut, right? So ut in this case, it's either put or I think it's either that's the only way. The only possible way will be put
Mm-hmm.
from but, right? So and then I will be incrementing. Yeah, so I have to return helper one plus
Mm-hmm.
helper, and otherwise I'm gonna be returning helper. So yeah, I think that's pretty much in. So I started with. I'm currently now I'm at put. So I changed from bit to but. Uh, so bit to but and then put. So again I will do the same iteration. Index will be zero with put is equal to
Mm-hmm.
index is equal to zero. Now I'm gonna do again. I will file all the words that ends with ut. So in this case, the only words that end with ut is there's nothing. There's only
Nothing. Right.
word. Yeah. So I will increase my index to index is equal to one with word is equal to put,
Mm-hmm.
and I will find everything that starts with p. In this case, it's gonna be pot and pog,
Mm-hmm.
and then ends with t. So there is only one word that is possible that is pot, right? So my next word will become pot,
Yeah. Okay, got it. Looks like
and
we're out of time. And what about time complexity? Do you still think that that is equal from n?
yeah, it's gonna be still big because I think we only are storing lowercase letters, right? So we try is limited. Otherwise, it would have been exponential, right?
I think it will be exponential time in your case, or at least like n squared, because you want to iterate over try more
Yeah,
than n times.
iterating over try is gonna take. I mean, like the search function takes on of try, right? And then we are gonna be doing that operation n times. Yeah. So yeah, it's gonna be of n square.
Okay.
I mean, it should be exponential as well, but since we are limiting exponential to 26, so that's kind of like a constant. Otherwise, it would have been exponential.
Mhm.
Uh, so it's gonna be like each search operation, it's gonna take on or like on time.
Mhm.
Each try operation is gonna take on time. It's gonna take on raised to the power 26, but since 26 is limited, it's gonna still take on time. Sorry, it should take O of 26 raised to power n, and that's again a constant number because we are limiting by letters. So it's going to take,
I mean, we can calculate and like search, it will be a constant time. That's nothing.
no, it's not going
But
to be constant.
you call it in for each loop on line 41. Then you call for each loop in one on line 75, and I see two inner for each loops, and
Yeah,
also you
that's what.
call 18. Yeah, maybe I'm wrong, but again,
Yeah.
let's continue.
Yeah, I think we can swap roles.
Yeah,
Yeah.
let's try.
Again, I could not have implemented this in like 20 minutes because given the, I mean, it's like a try is a complete data structure that needs a lot of time.
Honestly, you shouldn't use try here, and you just you can use, for example, Q here, and that's it. Uh,
Okay.
yeah, but you can find, I think, answer later for this question. Usually, you should use something like a Q here, and then like and then check differences. If there is difference for only one character, you put element into the queue, and that's it. And
Yeah, I don't think that would be efficient. I think that would be a bit more inefficient than the try. But
yeah,
yeah,
but you can, I still think that on interview, like on a real interview, you should show like a working code. Because for now, for me, it doesn't work. For me, as for interviewer, like you have a lot of mock and like you have an idea, but without any working solution. And
okay. Yeah. I think we can swap roles because
yep,
again, like I mean, when I was discussing, I could have like just talked about like these are the. I mean, I just went into the optimized solution, but I could have talked about which one you want me to implement. Um,
yeah,